Okay, so continuing with collecting data, we're now moving into surveys, which are a method to collect data. All right, surveys are a type of observational studies. First, we're going to begin with the census. A census is a counting of the entire population. In other words, every element of the population is surveyed. We don't do this very often because it's often difficult. However, if we do perform a census and successfully survey the entire population, then we don't need statistical techniques because we actually know the population parameter. There is no estimate. It's not a subset. It's the entire population. Okay. So a company employs 10 executives, each with a supporting secretary. The HR department wishes to determine the difference in mean salaries between these executives and their secretaries based on the most recent pay slips. A calculation is made for mean and standard deviation of the 10 executive salaries and similarly for the 10 secretary salaries. A t-distribution is used to calculate a confidence interval for the difference in the means. What is the principal mistake made in this calculation? Well, they had how many executives? 10, with 10 secretaries. And how many did they survey? Well, they survey all of them. So they conducted a census. So the first one, it says there's no reason why the population salaries can be assumed to be normal. I understand why you would say that because sample size was less than 30, but they conducted a census, so that's not the issue here. There's no reason why the population salaries can be assumed to be independent. They probably aren't because they're from the same office, and one executive's the executive's salary and secretary's salary are probably fairly related within the office. There's no indication of a lack of outliers in the respective populations. We really don't know anything about that because we don't have enough data. A one sample confidence interval using the set is more appropriate. It's not that because, once again, it was a census. We shouldn't have run it to begin with. Using data from an entire population makes finding a confidence interval appropriate. It should say inappropriate, but it makes it, we should not be using, since we have it for the entire population, since we ran the census, this was not the right thing to do, okay? Since we ran a census, we should not have run a confidence interval. We had the actual data. We didn't need to make an estimate. We were 100% sure what the difference was. Simple random sample. This is the gold standard. It is basically where you start with statistics. This is where you put everyone's name in a hat. The entire population is numbered. You drop all the numbers in a hat. You mix, stir, and then you grab a sample from that. All right. Every possible sample or desired size has an equal chance of being selected. This only occurs in simple random samples. So if I put the entire population of Reagan students in a hat and mixed and drew, it would be possible that I could get any possible combination. I might draw 30 names and all of them be freshmen. That wouldn't be representative, but it would have been random, and it happened by random chance, and sometimes that could happen. But we use simple random samples typically when we are able to include the entire population. So a simple random sample is defined by the method of selection, examination of outcome, both of the above, how representative the sample is of the population, the size of the sample versus the size of the population. It's actually defined by the method of selection, all right? Which means we put everyone in a hat and mix. The entire population had a chance of being selected, and every combination had a chance of being selected. We don't define a sample based on what the outcome is. So that's false. So therefore C had to be false. How representative the sample is of the population, we don't get to look at that. Sometimes samples are representative, sometimes they're not, even if we do them correctly. So that's not it. And the size of the sample, you can have a sample of size 1, you can have a sample of size 100. We don't get to look to compare the size. Size does impact whether we can run specific tests, but not this. Systematic sample. A systematic sample means we randomly select a starting point, and then we choose every nth person, all right? Typically, we like to do this for large data sets, like we're standing at the mall. Well, I guess that's not a good idea now, but if we were standing at the mall when they're at Christmas time, when there's a lot of people flocking in, we might choose every 50th person. Or if we were trying to get the views at a football stadium during an NFL game, we might choose every 100th person or 1,000th person, and we would randomly start with some seat number and then select every 100th or 1,000th person after that. So a human resource department plans to survey 100 of the 3,000 employees at the firm. An alphabetical list of employees is available. A random number between 1 and 30 is picked, and the sample consists of the person that far down the list together with every 30th person after that. Because it is every 30th person after that, this makes this a systematic sample. Now, had they just put all the names in a hat, all 3,000 employees in a hat, and drew 100, that would have been a simple random sample. But because they chose every 30th, that made it a systematic sample. Oh, one other thing. There's only one simple random sample. There's no special cases of simple random samples. All right. Now, all good sample surveys involve randomness, but there's only one simple random sample. Cluster sample. The thing about a cluster sample is the population is divided into groups that mirror the entire population. So a cluster sample basically says that each cluster needs to look like the population. So if I had a population that had 100 A's, 100 B's, and 100 C's, each one of my clusters would include A, B, and C in proportion to the population. All right, so each cluster needs to look like the population. It would need to contain the same elements as the population. So a candy manufacturer wants to test consistency of the sugar content of chocolate-covered cherries produced in one factory. The company decides to randomly select 3 boxes of chocolate-covered cherries from each day's production run at the factory and analyze every cherry in each of these boxes as to the sugar content. What type of sampling is this? Well, first off, every box of cherries should look about the same. They should be similar. So consequently, each box is similar, so each box represents a cluster. Once you randomly select a box or boxes, then you must sample every single chocolate in them. So a cluster sample, you randomly select a cluster that looks like the population, and then you sample everything within that cluster or clusters. So that would be what a cluster sample would look like. Stratified sample. We often confuse cluster with stratified. And I'm going to take a moment, and I probably should have done this already. Let's just say we had our population ABC, 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 ABC. Well, if I circled it this way, each one of these circles in red would be clusters because they look like the population. They all contain each element. However, if I had that same ABC, 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 and I circled it this way, A, B, these would represent strata. Notice within the strata, they look very similar. This is all A's, so yes, every element's similar. All B's, every element's similar. All C's, every element's similar. So with a stratified sample, I'm going to divide them in groups based on the characteristics, in which case this is group A, this is group B, and this is group C. And once I've done that, I randomly select within the sample. So I might randomly select this letter A, this letter B, and this letter C. But that's where the randomness comes in. They're forced into groups, and then I randomly select. Here, this is my group, and I randomly select the group, and then I survey everyone. So let's just say I selected this group, and then I'd survey all A, B, and C. Okay? So that's the difference between cluster and stratified. All right, so a research planning a survey of school principal in a particular state has a list of school principals employed in each of the 125 school districts. The procedure is to obtain a random sample of principals from each of the districts. So now we're selecting from each of the districts. So it's like, okay, rather than grouping the list. So this is going to be, because I'm selecting from each of the districts, this is going to say, hey, we divided it by district, and I'm selecting some from each district. So it's like, oh, here's a district, here's a district, here's a district. So I selected from each of the districts. So this makes it a stratified sample. Which may give comparative information that a simple random sample wouldn't give. All right, so this is a stratified sample because I surveyed a sample from each of the districts. So I had 125 of these, and then I chose within each of the 125. Each of the NFC teams carries a 53-man roster, a sample of 48 players. 5.6% of all 848 NFC players is to be randomly selected to undergo drug tests. To do this, each team is instructed to put their 53 names in a hat and randomly draw 3 names. Will this method result in a simple random sample? And the answer is no. Because for it to be a simple random sample, I would have to put 848 names into a single hat and draw. Here I basically had 16 different hats. In other words, there had to be a chance that all the players came from the same team, and in this particular case, that's not possible. So no, while each player has an equal chance of being selected, each group of 48 players does not have the same chance. Although it would be unlikely, it would have to be possible for me to put all the names in a hat and draw all names from the Dallas Cowboys. All right? But because I divided it into 16 teams, the most I can get from any one team would be 3. So this is not a simple random sample. This would be a stratified sample where each team was assured of being representative. And that's one of the nice things about a stratified sample, is we know that every single unit has an opportunity being selected. Thank you.